Company. I'm a product marketing director in the company. And today our session is about the challenges that you as ISP have in this new area, in this new time, and what are the innovative way to address them. So the agenda is, first of all, I will start with introducing shortly who is RADWIN. Then I will talk about the wireless ISP challenges. Then we will talk about innovative way to address these challenges. And then we will do a summary, and I will show one clip. Okay, so about RADWIN. RADWIN is a leader provider in the broadband wireless access market. Our customers, basically two types. One of them are service provider, tier 1, tier 2, tier 3, as an example, Enlace, Telmex, and many others, and also ISPs. This is in the part of service provider, and we also have other type of customer which belong to the strategic market, which are transportation, utilities, as oil and gas, electricity, municipality, and we provide different solutions for this customer. Basically, our solutions are based on for application of fixed and nomadic and mobility. We are not going to talk here about mobility. We will talk about fixed application because this is what you are doing. The product, as I mentioned, okay, what else? This is for this slide. Our headquarters is located in Tel Aviv, in Israel. We have offices worldwide. In Latin America, we have about 4 different offices, one in Mexico City, another one in Colombia, in Argentina, and also in Central America, in San Salvador. We have more than 100 different networks of tier 1 operators that our equipment is deployed in their network. And over 170 different countries. So this is about RADWIN. As you can see here, this is a short list of our customers: T-Mobile, AT&T United States, Verizon, and many other, Telmex, Claros, Movistar, Telefonica, Digicel, and many others. As I said, Total Play, Tigo, Entel in Chile, many of them. In the United States, we also have ISP because this is a big market, and as I see today, your market is growing as well. Here you can see, I think you don't see it good, but this is basically our portfolio, point to multipoint, point to point, and we have also recently launched a smart communication node, which is very applicable for ISPs. Okay, this is about RADWIN. So let's start and discuss what are the main challenges for ISP. I believe there are many, but I will talk only on a few of them, which I believe are the major one. Well, the first one, and I believe everyone feel it, is the need for more capacity. And the reason for it mainly is because of the video. Today, 70% of the traffic over the internet is video. And the reason is over-the-top application. When I'm saying over-the-top, it means that the provider is just a pipe and the application coming from somebody else. Take, for example, Netflix. All of us belong to, want to see Netflix. In the United States, we see many customers cutting the cable and taking decision to be connected only through the ISPs or carriers, but don't need any cable TV. They are watching the TV over the internet. And this is generating a lot of demand for traffic, and I believe you feel it today and you feel it in the near future. The problem is that the growth of this need for capacity is very high, about 30% every year. I mean, you see that the capacity over the air, over the internet is become higher and higher at about 30% every year. And at the end of the day, you as a provider of access to the end user feel it very well. The second point, which I believe, the second challenge, which I believe you feel it very well, is the lack of spectrum. Let's take, for example, the 3.5. 3.5 in Mexico, unfortunately, I believe will never be will be available for you. And if we look worldwide, the 3.5 gigabit per second will be used for the 5G, for the next generation of the mobile services. So below 6 gigahertz, and usually this is the band you would like to work in, because it's going very well with a near line of sight and sometimes even non-line of sight, the only way to work is in unlicensed. Unfortunately, what we see is that the unlicensed become very congested. And why is that? First of all, there are more and more Wi-Fi outdoor based on 802.AC or N. It's in the market. Every one of us use the Wi-Fi in the street, use Wi-Fi in the restaurant, whatever it is. But more than that, the cellular operator today are not using just licensed band. They are using also unlicensed band in order to increase the amount of capacity that they can deliver to their customer. Beginning this year, many operators, the technology is there, the equipment is there, and many operators transmitting now also in this unlicensed band that I believe all of you are using it. Am I right? Yeah. Right? So the bandwidths become very congested. If you look, for example, in main cities, you will find a level of about minus 50 dBm, which is very relatively high. When you go out of the city to the outskirts of the city, you will find minus 60, minus 70 dBm. Maybe in the very rural, you will find less than that. And this is a real challenge. Why? Because when the air is interfered, when the spectrum is interfered, the capacity that can be reached is not high. And the utilization of access point or base station that is used for transmission, the utilization is very low. You can get maybe half of the capacity, maybe sometimes less. Sometimes it's not synchronized. And less of capacity means more towers, means more access point. More access point means more interference. And at the end of the day, what you would like to achieve, as I mentioned before, is capacity. And this unlicensed interference is one of your main challenge to address the capacity challenge. The next trend that we see more and more fiber connected, mainly in the cities. So those of you that provide service inside the cities, I believe some of you start seeing the competition with the fiber operator. One of your guys told me today, I'm not getting into the center of the city because I don't want to compete with the fiber, and the interference is very high. Okay? And if you want to compete, you need to be able to deliver enough capacity. Today, fiber delivers 40, 50, 100 megabits per second. The latency is very low, and the link is stable. There is no fluctuation of the capacity because of the interference. So I think these three challenges are quite big. Here there is a Wisp in Mexico. There is also Wisp association in the United States. Very big one, very mature one. And last year, they did by Carmel Group. They made market research within ISPs, and they asked them, what make your customers leaving you? And the answer was, first of all, because of the speed. 36% said we have a problem with the speed. Another 34 talk about the service performance. I believe it's related to many aspects. The fluctuation, the stability of the service, the latency, and many other things. And also the competition and the cost. Another question that this market research asked these ISPs, there was about almost 200 ISPs that were part of this research. They have been asked, what harm you? What is your best problem that not let you grow? And they said, the first point is lack of available spectrum, and we discussed it. And you see, the rating average was 9. The second point was noise and interference, and we discussed it. So I'm not talking nonsense, I'm talking on something that have been approved by many ISPs in the United States. The other point was related to the government regulation, and the last point was related to the increased total cost of ownership. That means the CAPEX and the OPEX of the network, mainly the OPEX. And I would like also to discuss this. So if we are summarizing shortly, up until now, what are the main challenges that you as ISP have, as I understand, as I see it, is the need for more capacity, the 5 gigahertz interference, the lack of spectrum that we discussed, the fiber competition, and the operational cost. And I would like now to discuss each one of them and to offer some ideas that basically we implemented in our solution. Sorry. Okay, so innovative solution to address these challenges that I just mentioned. The first one that I would like to discuss is the spectrum interference. Well, here is a picture. You can see from the point of view of a base station, this is the base station. Usually, the antenna that is used is relatively wide. Okay, you want to get maximum users from one access point, from one base station. Therefore, you are using 90 degree, 120 degree, whatever it is, wide antenna. What's happened is if there is any interference coming from this direction or from this direction, from any tower in the area into this base station, it cannot receive the signal from a remote unit. It's like somebody shouting in your ear and you cannot hear anybody else. So what is the way to address it? Let me show you a way to avoid this interference. What we are doing is we reduce the size or the span of the antenna. It was 90 degree. Here you can see it's about 60 degree. And we reduce it more and more. And we take it in about 8 degree, very narrow. And now, when the base station would like to talk with this customer, he steer or he align the antenna to this customer. And then when we want to talk to another customer, he steer the antenna or align the antenna to another customer. And this is done in a very fast way. Is it clear, the idea? So the span is still 90 degrees, very wide. But the communication is like one-to-one. There is only the base station hear and talk, it can hear, because the antenna is very narrow, only with the subscriber unit. All the interference around is not heard by the base station. You can see now that if there is interference, this is a source of interference. Coming into the base station does not receive it because he points to the subscriber unit. And even though if now he's talking with this subscriber and the interference is coming from a different direction, is out of the main beam of the antenna. The idea is clear. Very important that the idea will be clear. This is what is called beamforming. We shape the antenna into very narrow beam, like a point-to-point. each one of you would be happy to transmit, to use a point-to-point to each customer. So you will get longer range, higher capacity, and very good performance. But if you will connect 20 users, residential users, that pay $15 a month, let's say 200-300 pesos, to you, you will not be able to earn because point-to-point is very expensive. So this is like a point-to-point with economy of point-to-multipoint. The idea is clear? Sure? Okay.
That's made by software? Or
by software. Everything is software. The antenna is moving from one customer to another in every 1 millisecond. Everything is software. Okay, let's continue. Here you can see what is the result. Okay, let's look on this axis. This is the amount of interference. Minus 90 dBm, then interference is increased to minus 80, minus 70. Here is the CT, very high interference. And this is the capacity you can achieve. What you can see that where there is no interference, and by the way, you can see here two graphs. One of them is regular base station. This one that you are using today, either Ubiquiti, Mimosa, Cameo, whatever it is. And this is the solution, the performance of beamforming antenna on the base station. And what you can see is that there are more interference, the capacity is reduced. But see what's happened. When the interference went from 90 to 80, the capacity of regular base station reduced to 130, but the base station of the beamforming stayed the same. So here is about, let's say, 30% more capacity with the beamforming. Then, when you increase more the interference, is doubled. The capacity is become doubled. And when there is interference in, let's say, in the main of the city, it's triple time the capacity in the same spectrum. Both of the solution using the same amount of spectrum, 20 megahertz, 40 megahertz, whatever it is. You can see that the beamforming reduce its capacity in a much lower way. Is it clear? Okay, let's continue. So this is about addressing the interference. Using beamforming antenna with a narrow beam, so interference is not getting in. Now let's talk about lack of spectrum. Still, what I'm going to talk now is applicable for licensed band, if you have licensed band, or to unlicensed band, it doesn't matter. The idea here is the same. Okay, let's see. We have only one slide about it. Well, if you have a very narrow road and you want more car, you should make the road very efficient. Somehow, I don't know how. Maybe you need to build many, above this road, many other roads in order to increase the flux, to let more cars going through this road. So here is the same idea. What you need to do, if you have small amount of spectrum, what you need is to select technology that allows you to transmit more bit per second on the same spectrum. For example, if currently you are using in 5.8, you are using 40 megahertz, many times there is not enough spectrum there. So using, some of them is very interfered, so you find 40 megahertz, which is clean, and you can use it. But now you need to use it not just by one sector, but by many. So the amount of spectrum is relatively small to each one of them, but you want to get more from each one of the sector. How you do it? So let's see. Here is the way that I believe most of you deploy your network today. What you can see here, this is a site. This is one site, second site. Here you can see 9 sites, 9 towers. Each one of the towers is using 4 sectors, 4 access points. Each one of the access points different direction. Now, if you will use in this solution, if you will use only single capacity, only single channel, frequency channel, there will be a lot of interference. And this is what you currently have. you need to use 4 different frequencies in this network. You can see, in this side, you have 2 frequencies. In the other side, you have another 2 frequencies. And this is the way mostly today is deployed, sometimes even worse. I mean, in this case, what you can see is that with the spectrum you have, whatever it is, you need to divide it into 4. Why to 4? To enable to avoid interference. Okay? So if, for example, you have 60 meg, you can now use, let's say take a 40 megahertz, which is clean. Each sector can only be 10 megahertz, not much. What is the better solution? Let's see. There are solutions in the market, and this is again because of the beamforming that allows you to use only 2 frequencies. So for example, if I have, here an example, if I have 80 megahertz, I can get from one side 600 megabit per second. If I have the same 80 megahertz, now because I need to use only 2 frequencies, I need to divide it to less slots. I can now have, from the same amount of spectrum, 1.4 gigabit from the same 80 megahertz, because I can reuse the frequency more times. You can see there are only 2 frequencies in this network. This is what beamforming allows you. And why is that? Because the antenna is so narrow that it does not interfere to the side nearby. It's not just the beamforming, not just immune from others' interference, from Wi-Fi or others, but also from your system interference in other sites. So in other towers. So here you can get more capacity. And in the future, this is our plan, is to get into a way that you will be able to use only 1 frequency in all the network. So if you find 40 megahertz channel, 80 megahertz channel, the same 80 megahertz will be used. It's not available yet. But this is what beamforming allows you to have. And then you will be able to get 3.7 times more than this case, which is 2.5 gigabit per second on the same 80 megahertz. Only by improving the reuse of the frequency within the network. Is the idea clear? Sure. Fine. Let's continue. So this is the way how you can compete and utilize or deliver more capacity to your customer, even though you have a limitation in the spectrum that you have, whether it's licensed or unlicensed. And now let's go to the third point, which is the operational cost. In order to explain our way to improve the operational cost, I would like to talk or to discuss firstly what is the process, or what is the let's say operation flow that you have in your companies. Well, when you are an entrepreneur and you took decision to build a network for your customers, some of you deliver service to 500 users, some of them for thousands, and you are moving from one area to another area. And when you start the deployment or the network, first of all, you put infrastructure. What is the infrastructure? You select which size, and you put the tower or use tower of others, and put base station on the tower. When you have an area which is covered by a base station, you start selling the service. Customer call to you and ask to get a service from you, and then you are happy. The next stage, and if you have many customers, you need to send to the end customer premise, to the home, to the house of the customer. You need to send some teams to deploy. So you need somehow to manage these multi-teams that the installers that are going to the field and do this deployment. And eventually, each one of the team need to do the installation. Okay? What I would like now to show is that per each one of them, there is a way to reduce the total cost of ownership for you, to make your life easier, to be able to execute this operation with less amount of people, sometimes even with less amount, with less skills. So let's start. I think the first stage is very clear, and this is not innovative. I don't know, how many of you today, when you deploy a network, a new network, do you plan this network? Okay. How many of you do not do it? Okay, never mind. Anyway, doing a planning of a network is crucial. If you do not plan your network, nobody can really, I mean, once you plan the network, you optimize your cost, because you know you find the right size of the base station. And then you minimize the amount of site. You minimize the amount of access point that you need to install. You know exactly what capacity you have in order to deliver it to your customer, so your customer doesn't feel that he missed some capacity. And as I mentioned before, you do not spend too much money. Now, this process is crucial, and I believe that many of the companies provide this capability, and this is innovative, but I would say it's there in the market. Another point is when you want to sell the service. Somebody called to you and say, okay, I want to get a service. How do you know if you cover him or not cover him? If there is a line of sight to these customers, you go to the map. Sometimes you say, okay, let me check, I will check and I will come back to you. Or you look on a map. What other solution is available, or I offer you, is if you did a plan of the base station, and if you also sign or indicate into the plan which base station you really deploy, because you may build a plan of 20 base stations, eventually you deploy only 3. If you enable to the plan, and this is not available today by anyone, to update the planner, the software. Okay, I planned 20, by these 3 I already deployed. Now we offer a tool that allows you to, by click, it's a web-based, by click, to ask the planning whether this customer, based on his address, is covered or is non-line of sight. More than that, the customer may say, I want to have 40 megabits per second. You can give, you cannot give. The software give answer. The line is available. I mean, the user is covered. And the capacity that can be delivered in this or other, 40, 20, 10, whatever it is. So, on the spot, your customer call, you give an answer, and you go to the next step. You go to the sales process. Okay? This is part of the planning tool. Now, when you need to go to you need to send people to the field and do the installation process. The question is, by what means today your customer or your installer know what you need to do? He get the paper, on the paper is written, go to this and this customer, take this and this subscriber unit or CPE, and install it. And then, after he do the installation, he lose this paper. He did some tests. He measured -50, -60. I don't know what he measured. Nothing is not documented. And sometimes you need to send back the installer because there are some problem. The installation was not done good. Now, if you have many installations, and I'm not sure this is the case, but if you have 20 or not 20, 3, 4 people, installer in the field, you don't know if they are efficient, not efficient, how much time it took them to do the installation, if the installation was done good or not good, right, according to the standard or not. So this tool, the deployment manager, what he's done is make all this process is streamlined, it's automated, all this process. I mean, when you sell you sell the service, there is input. It can be from other machines into our tool, and you can assign this installation to one of the group, and sometimes it's subcontractor, it's not yours. It's other contractor that you don't have any relationship with. You have a relationship, but you are not managing it. Okay? And this information, once you select the right installer, is transmitted over the network into a handset. And I will show it in a minute. Into handset. This is a standard handset that every installer has. The installer needs to download the application from the store, and all the work order, where the customer is living, what equipment to take, what capacity you would like to get, all the parameters are downloaded into this application. What the installer needs to do is go to the customer and download. It doesn't need to write any parameter. It just needs to communicate through this handset with the subscriber unit over Wi-Fi. The subscriber unit has Wi-Fi. It downloads all the parameters. This application also align. There is a wizard that he looks. You need to do this process and to align the right direction of the subscriber unit. Then he do verification test. What is verification? He check that the capacity the customer order is done all over the way. Okay? And only then he can send with pictures how the installation is look. Is it okay? Is it according to the standard? The information is sent to the network, and now the guys that is sitting on the NOC, the manager of the deployments, say, okay, before you leave the place, let me look how the installation is done. He can look on the results, he can look on the RSSI, whatever it is, and say, okay, V, go. Okay? This is the idea. Streamlining all the process. The idea is clear, right? Okay, so we discussed on 3 different problems. One of them is the interference, we said beamforming. One of them is the spectrum, lack of spectrum. We said the right way is to reuse, to increase the reuse of the base station, of the network, of the frequencies in the network, and this is again because of the beamforming is possible. And then we talk about a way to streamline the installation process and to reduce all the operational costs that you need to pay. I would like now to finish or to complete this session with a video clip which explain in very nice way what we deliver or what beamforming gives you and what you can achieve. And this is basically the RADWIN Jet product that is available. We sell it to operators worldwide, in United States, to high tiers operator and to ISPs, also here in Mexico to tier 1 and 2 operators that are using it. And now the time we made the right change in order to allow you as ISP to use this equipment with a affordable price, because the equipment was built for business customers, for operators, and now since the last year we have this solution also for ISPs. Okay.
Los proveedores de servicios inalámbricos se esfuerzan continuamente por aumentar la capacidad de la red para atender más suscriptores ofreciendo mayor capacidad. Sin embargo, los proveedores de servicio que operan en bandas licenciadas de 3,5 GHz se encuentran con la problemática de la falta de espectro y de capacidad reducida de los sistemas punto a multipunto WiMAX. Los proveedores de servicio que operan redes punto a multipunto en bandas no licenciadas también afrontan dificultades para cumplir con los SLA debido a los efectos adversos de la interferencia de señal de sistemas de terceros. Buscando redefinir el rendimiento del acceso de banda ancha inalámbrico, se introdujo en el mercado RADWIN 5000 JET, una disruptiva solución punto a multipunto con beamforming inteligente. La solución JET con beamforming consta de un conjunto de elementos de antena que se combinan para generar un haz estrecho y orientable para una mayor ganancia del sistema de cara a potenciar la capacidad y el alcance. La inmunidad a la interferencia se mejora inmensamente como resultado de reemplazar el amplio haz de las antenas sectoriales comunes con un haz directivo. Junto con la interfaz aérea especial de RADWIN, JET asegura servicios con SLA garantizados en espectros ruidosos donde las soluciones convencionales no pueden operar. En las implementaciones punto a multipunto típicas con antenas sectoriales, los sectores adyacentes del haz se sobreponen, creando un alto nivel de autointerferencia que reduce la capacidad del usuario. Al contrario de las antenas sectoriales típicas, el haz directivo de JET reduce al mínimo las autointerferencias entre sectores adyacentes y sitios cercanos, logrando una mayor capacidad de red por medio de una reutilización de frecuencias sin igual. Cuando hay problemas con las condiciones de línea de visión, la antena con beamforming de JET automáticamente elige la dirección de haz óptima para lograr el mejor alcance por una ruta de reflexión o difracción, dotando a los proveedores de servicio con una mayor cobertura y mejor utilización de la infraestructura. RADWIN 5000 JET ha sido seleccionado e implementado comercialmente por los principales operadores de todo el mundo. Los proveedores de servicio para quienes RADWIN es nuevo pueden actualizar sus redes a RADWIN 5000 JET fácilmente para obtener el mejor rendimiento de la industria. Los proveedores de servicio que ya trabajan con soluciones RADWIN 5000 pueden aumentar el rendimiento de sus redes fácilmente, implementando estaciones base JET que son compatibles con las versiones anteriores de las unidades RADWIN 5000 de los suscriptores. RADWIN 5000 JET es una solución punto a multipunto superior y preparada para el futuro, para el acceso inalámbrico de última milla y el backhaul de redes. Si está buscando hacer crecer su red, RADWIN 5000 JET es la solución perfecta.
Here is the base station. This unit delivers 750 megabits per second, and it's really immune to interference. It's very easy to deploy. You don't need two people. One people put on the tower. Very low power, 25 watts. It's in the size of 13-inch pieces. Any question? Yes.
Regarding the frequency reviews,
Yes.
Sometimes we found that, for example, in one sector, we found that there is a low interference in a specific frequency, but in the opposite side, maybe not, probably not. So my question is, in real life, do you know any success case in which the ISP is using the reuse of frequency?
Most of our customers, I should say, are using two frequencies all over the network. Today, I know I'm well familiar in the United States. People there are really suffer from lack of capacity, lack of spectrum. Sorry, they find here 20 meg, there 10, 20 meg, and they really need to utilize the minimum possible. And if they can use more than that, they are using more. I mean, if you can use more, I mean, the best station deliver over 80 megahertz channel. And if you can work over 80 is the best, then you can get the full capacity. But sometimes what's happening is you cannot. And then you increase, by the way, the system automatically, something that I can mention. What's nice with this solution is that you can set the following. You can say, I work on 80 megahertz channel. The unit itself automatically, I mean, if there is no interference, you will get the full capacity. If there is interference, the system automatically reduces the channel bandwidth to 40 to 20. And if the interference is vanished and not appear anymore, the capacity, the channel bandwidth increased automatically to 40 and 80. This is dynamic per subscriber unit.
Can we connect another brands, another CPE brands to this one?
No, this technology is proprietary, the beamforming is proprietary. Also the air interface, I mean at the beginning we had base station with no beamforming, with passive antenna. 90 degree, 120, and one of, I would say, if you think about RADWIN, the main value that RADWIN brings to the market worldwide, it's point to point or point to multi-point, with beamforming or without beamforming, is the air interface. We have many different mechanisms and algorithms that allows us to avoid the interference affecting your service. This is the main, expertise that RADWIN bring to the broadband wireless access, ISPs or operator. So, but this is proprietary. Any other question? Okay, for the near future, I would say the short future time, we plan to allow to the member of association. We're doing a campaign which allow you to check and to get experience with RADWIN equipment, and we plan to send to each of you over email the campaign details. Sure, the campaign include pricing that will make you happy in order and will make you ready to buy and test. And I'm sure, I no doubt about it, you will invest and buy another one because the performance are great. Okay, thank you very much for the time you spent for us, and I hope I gave you some ideas how you can improve your service into your business customer or residential one. Thank you. Yes. Yes, you will get all the information about the vestige, about the subscriber. Our subscriber built to get up to 200 megabit per second. This is in United States. Our customers using usually 50 and above. Nobody today in the United States uses 25. They are going 50, 100, and this is the approach there. And I know that here is different, but you will get there, no doubt about it. It's only a matter of time.
Okay, thank you.
Thank you.